Memory-Augmented Networks and AI. Memory-augmented networks. MEANs are a type of artificial neural network that incorporates an external memory component to enhance its ability to learn and reason. This architecture is inspired by the human brain's ability to store and retrieve information from memory, allowing it to perform complex tasks and make decisions based on past experiences. In traditional neural networks, the information is processed and stored within the network's weights and activations. However, this approach has limitations, particularly when dealing with tasks that require long-term memory or the ability to recall specific details. MEANs address this limitation by introducing an external memory module that can store and retrieve information independently of the network's weights and activations. The external memory module in MEANs is typically implemented as a separate component that interacts with the neural network through read and write operations. The network can write information to the memory module, which can then be retrieved and used to inform the network's decisions. This allows the network to learn and reason about complex tasks, such as natural language processing, image recognition, and decision-making. One of the key benefits of MEANs is their ability to learn and remember specific details, even when the input data is limited or noisy. For example, in natural language processing, a MEAN can learn to remember specific words or phrases and use them to inform its understanding of the input text. This is particularly useful in tasks such as question answering, where the network needs to recall specific details from a large corpus of text. MEANs have been applied to a range of tasks, including image recognition, natural language processing, and decision-making. For example, in image recognition, a MEAN can learn to recognize specific objects or patterns and use this information to inform its classification decisions. In decision-making, a MEAN can learn to weigh the pros and cons of different options and make decisions based on past experiences. According to a study published in the journal Neural Computation, MEANs have been shown to outperform traditional neural networks in a range of tasks, including image recognition and natural language processing. The study found that MEANs were able to learn and remember specific details, even when the input data was limited or noisy. Another study published in the journal IEE, Transactions on Neural Networks and Learning Systems, found that MEANs were able to learn and reason about complex tasks, such as decision-making and planning. The study found that MEANs were able to weigh the pros and cons of different options and make decisions based on past experiences. MEANs have also been applied to real-world tasks, such as language translation and text summarization. For example, a study published in the journal Association for Computational Linguistics found that MEANs were able to improve the accuracy of language translation tasks by learning to remember specific words and phrases. In addition to their applications in natural language processing, MEANs have also been used in computer vision tasks, such as image recognition and object detection. For example, a study published in the journal IEE, Transactions on Pattern Analysis and Machine Intelligence, found that MEANs were able to improve the accuracy of image recognition tasks by learning to recognize specific objects and patterns. Overall, MEANs are a powerful tool for artificial intelligence, allowing networks to learn and reason about complex tasks and make decisions based on past experiences. Their ability to learn and remember specific details, even when the input data is limited or noisy, makes them particularly useful in tasks such as natural language processing and decision-making.